Hello there, and thank you for watching once more. I'm Michael Fudge, and this is our second video in our series on mastering the SQL SELECT statement. In the first video, we looked at the projection line, and in this video, we will explore the where clause. You're welcome to follow along with me using the Learn Databases environment. If you click on the link applydb.com, there will be details there. So in this video, we're going to cover the where clause, and specifically, we'll look at relational operators, logical operators, checking for null in the where clause, the set operator, in or not in. We'll use between. We'll do some pattern matching with like, and then we'll also explain that actually the where clause happens before the projection itself. So those are the things that we'll get to in this video. Okay, here we are out in Azure Data Studio again. We're once again going to use the TinyU database, and the TinyU database has these tables in it. And I think we'll start with the students table. Let's just pull everything. Now, when I say select star from students, I'm getting all the rows and all the columns from this table. If I want to just get a specific student out, I can add the where clause and then specify the match of what I want. Maybe I want all of the freshmen in this table. So I could say where student year name is freshman. And then this query will just retrieve out the freshman from the data. So this here is what's called a selection. What we learned before was called a projection. This is called the selection, and this determines which rows we see in the output, whereas the projection determines the columns. For instance, I could maybe just get the names of the freshmen doing this. I could say select and then here I'm going to say student first name and student last name. I should probably, well, we'll just finish it up. Student year name is freshman. Okay, so this is going to be, I'll just name this query for you, names of all freshmen. There you go. Now, how do you know they're freshmen? If you were just looking at this data, you wouldn't know that. This is probably why it's a good idea. It's not required, but it's a good idea to include the column that you are filtering in your selection in your projection. That way you know what it is that you're looking at. If I add this in here, now I know that I'm looking at all freshmen. Okay, that's just something that I've learned from experience. It's usually a good idea to include this column in your where clause, at least when you're building out the query, so that you have some confidence that you're doing it right. Okay. What other kinds of operators are there besides equal? Maybe you want to find all of the students that aren't freshmen. Students who are not freshmen. Select star from students where student year name is not equal to freshman. There you go. Everybody here is a junior or a sophomore or a grad student. You can use not equal like that, and I believe this also works. It also satisfies not equal in SQL. Maybe you want to see people that have a certain GPA. Maybe everybody that has a GPA below a 2.0. So students with GPA below 2.0. Right? This is where SQL becomes a great language, because you have a set of data and you can ask questions of the data. That's called querying the data. And you can easily, if you know a little bit of SQL, answer your own questions. This is what makes SQL querying so great and so attractive and so popular. So given a little bit of knowledge, you can express code in a way that retrieves the information out that you need. So where student, whoops, got to spell where right, GPA is less than 2.0. There you go. So those two students have a GPA below 2.0. Okay. Now you might want to do other things, like you might want to combine some of these together. Like you might want to say, I want to know students who are freshmen and have a GPA bigger than 3. Select. So for this, we need to use a logical operator. The logical operators are and, or, and not. So and says they both must be true to show the line, or says either one of them must be true to show the line. Not negates an expression. Let me break this up so that it's a little more... If I were going to write it, I'd probably write it like this. There. See, that's a clause. Actually, I'd probably write it like this. Right? So, statement, clause, clause. This clause goes under that clause. Let's see. Okay, there's 3 freshmen who have a GPA bigger than 3.0. See that? It's pretty neat. Robin Banks cooked my food and Oliver's stuff is missing. Now, what is and versus or? Well, or, if I did the same query with or, or student year name is freshman, I will see some freshmen and I will see some not freshmen. Because what I get back here is everybody that has a GPA over 3. And if for some reason your GPA is not over 3, then you're a freshman, right? Freshman. 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 So that's how OR works. OR is inclusive. Only one of these has to be true for that line to appear from that table. Okay. So another thing you could do is maybe you're looking, you want to do a range check, right? So you want to do a range check in numbers. Like, so maybe you want to say, give me all the students whose GPA is between 3 and 4. So you could say, or let's say between 2 and 3. So I can say select from students where student GPA between 2 and 3. Just do that. Very expressive. Okay, and if you look through all these, everybody's got a GPA in the 2s. So this is students with GPA between 2 and 3. Another thing I wanted to sort of mention here is I can always query by ID. Like maybe I want to find a very specific student, a student 17, right? So I could say select star from students where student ID, spell that right, Mike, is 17. Let's see who that is. That's validation. She's a junior. Why do I bring this up? Well, because I want to show you another operator. I want to show you a set operator that you can use called in. So this lets us find one student. And then I could use a set operator like this. I can say select, let's find, hold on. Don't talk and type, Mike. student ID. So let's suppose I want to find student 9, 17, and 10. I could do something like this where student ID equals 9 or student ID. I can't say and because one row can't have all the same ID like that. So it's or student ID is a 10 or student ID is a 17, right? I could do that. And there's my 3 students that I want. And just to show you that and will not work is because no one row can have all 3 of those student IDs at once. So and is not going to work. And it's just going to come back with an empty set because all 3 of those conditions could not be met for a single row. Remember, the where clause applies to each row in the data set that you get from the from clause. So in my table of all the students, can one of these rows have a 9, a 10, and a 17 all in the same ID? No, it can't. So and is not the right operator here. So this is pretty common to do this, and a better way to write this is using the set operator in. So it would look something like this. Select where student ID in (9, 10, 17). And let's put in 99 just to show you if it's, you know, if there's some values that aren't here, it's fine. It's still going to retrieve the values that match. Right? So it's not going to like close it out because you don't have a 99 or 100. It's just every time it makes a match, it appears. So in is nice. And you can also use not in as well if you want to negate it and get everybody but those 3 in there. You'll look at 9 is not there. 7, 8, 11. 9 and 10 are not there. Okay. So in and not in. What else we got? Null checks. Let's do null checks. So maybe we want to find every student that doesn't have any notes or a student without a major, right? One of these students probably, like, see this one student down here doesn't have a major. So we want to find that student, right? So we say, this is called a null check. Now you don't say equals null. Nothing equals null because null is not a value. You have to check for null. Null is a condition. So for example, select from students where student major ID is null. You're checking for a condition. Are you null? There's a student with null. Now to contrast that, I'm going to copy and paste this because it's wrong. Equals null should not work because you can't check a value against null. So that always comes up as null, as empty. So you don't want to use equals null, you want to use is null. You're testing for a condition. Null is a condition, not a value. So let's see if this works with the student notes, by the way. It does not, because technically those student notes here are not null, they're blanks. These are blanks and not null. Usually when they're null, they'll show up in the output as null in italics like that to give you an idea that the value is null. So likewise, you can find students that have a major, right, by just checking for null, not null. Is not null, where student major ID is not null. These are all the students with a major. Students with a major. Students without a major. So that does beg the question, how do I find all the students without any notes? How do I find students without any notes? Well, there's a couple ways you can do this. Let's take a look at some ways that you can solve this problem. where the length of the student notes is bigger than 0. I think it's len. You make this look a little better. So these are all the students. Whoops. Okay, it hit me. I figured it out. The students table has a type. The data type for notes is text, which is a large text type. And because it's text, I should have probably not used text. I should have used varchar max instead. I cannot run the len function over it, so I will have to cast it to varchar. So I'll have to say cast, take that length, and cast student notes as varchar. Then that should do what I want. Okay, so those 3 students have notes because the size, the number of characters in their field is more than 0. So that means there's notes in there. Okay, let's talk about 2 last things here. Let's talk about using like for pattern matching. So like is for pattern matching. For example, all the students whose first name begins with an L. Students with first name begins with L. Select where student first name like L%. Lola, Lee, and Lily. Oh, let's do this one. Okay, so let's find students whose second letter in their first name is an I. So check this out. Students with second letter and I. So like M-I-K-E, for example. That would be select from students where student first name like, I hit the caps lock button, underscore I, and then whatever comes after it is fine by me. This guy here says anything afterwards. This guy here is specifically 1 character. Let me change this back to like that. So Victor, Willie, Ginger, Lily, Michael. There we go. That's everybody in there. Third, let's make it, it's either an I, the second letter, or a A. So that's going to be like that, or student first name. I have to repeat this. I can't say student like I or like. It doesn't work that way. You have to repeat because it's technically a Boolean expression, which means this is one operand and this is another operand, and together it's a binary expression, and together they give you a Boolean result, true or false. Okay, so it's a binary operation. There's 2 values. So like, and then it would be underscore. Would I say A? %. I don't know if there's anybody that falls into this category. We'll find out. Yeah, there are Dan, Val. Okay. All right. So let's talk about our last thing, which is the dirty little secret of the select statement. And I'm just going to give you an example. This is called where before project. Okay. And let's do something like this. Let's say, let's take student first name, student last name, student GPA, and then 4.0 minus student GPA as difference, diff to 4. Remember we did this last time? And then you get this column here. Well, I want to find all the students whose diff to 4 is 1.5 or between 1.5 and 0. So you might say, well, that's cool. I could do that. I could say where diff to 4 between 0 and 1.5. And you can see already it's pissed at you. Invalid column name. Watch what happens when I run this. Invalid column name. Invalid column name. What the heck? Here's why it's invalid. Technically, the very first thing that runs in this select statement is this right here. This is the number one thing that runs. It grabs the table. Then, the second thing it does, it applies the where clause. Then the third thing it does is the projection. So if the projection is third, line 74 has no idea what diff to 4 is because it occurs before that. So the way you write it and the way it gets processed are actually different. And this is something that you really kind of have to know if you want to truly master the SQL select statement. You have to understand this. So what I have to do is use this expression. You know, I guess one way I could do it is just use this expression where 4.0 minus student GPA is between 0 and 1.5. And this gets ugly. And I guess I'll leave it like this and say this is an error. And then let me copy and paste it and get it to run correctly. Again, it's not ideal. But this is where the abstraction and the ease at which SQL operates sometimes does not always have a nice rosy outcome. There you go. If you look, everybody's diff to 4 is 1.5 or under in here. Again, this expression is ugly. You will learn later on ways that we can get around this. Okay, one way that you get around this is by using the with clause to create a table valued expression, which the output of which is a temporary table that you then query, and then it actually makes a little more sense and it's easier to use. Okay, but that is the where clause. And that is lesson number 2 in our series on the SQL select statement. Thank you.